Today we have a discussion on design of Rcc beam. So what do you mean by beam? So why we provide beam in structure? So basically beam is a horizontal member provided to transfer the forces known as axial forces or bending moment to the vertical member. So then beams can be classified in different types depending upon the end condition of the beam or the location of the beams in the structure. So beams can be classified in different types. So first we have simply supported beam, continuous beam, cantilever beam. Okay. Now we go to the basic representation of the simply supported beam, which is supported on a two masonry walls. Supported on a two masonry walls of having total depth d, effective depth small d, clear span of the beam which is known as L, center to center span of the beam which is known as effective span LE. Now we will have a representation of the skeleton structure of the beam. Now if you see the different elements of the beam. Now this is known as a bottom reinforcement, which is in case of simply supported beam. If you see, if you study the bending moment diagram, study the bending moment diagram. This is the nature of the bending moment diagram in case of simply supported beam. If you study the nature of the bending moment diagram, towards the support, the bending moment is 0, but at the mid span, the bending moment is maximum. So generally, in case of simply supported beam, the bottom steel, what we provide is generally to carry a tension force, and we provide a bars at top also. So these are the bars which is known as a hanger bars. In case of simply supported beam, we provide the bars at the top which is known as a hanger bars. So these bars, the main purpose is to hold up the stirrups in proper position. Okay. Now you can see the vertical element also. So this is known as a vertical stirrup. So stirrups can be classified as 2-leg stirrup, 4-leg stirrup, 6-leg stirrup. Okay. So depending upon the condition of the beam and requirement of the beam, we provide vertical stirrups. Okay. Now you can see this is a 2-leg vertical stirrup. Okay. Because the two vertical elements, so it is called as a 2-leg vertical stirrup. So in case if you see the nature of the bending of the vertical stirrup, you can see the bending of the stirrup here. Okay. As per IS standard, we should bend the stirrup in this way. As per IS standard, this bend should be at an angle of 135 degree. As per IS standard, because why we provide the bend at 135 degree only? Because in case of lateral force or a wind force, maybe wind or earthquake force, there is a lateral jump between the beam. So that time what happens? The links is try to open. So that's why we have to provide a bend in a proper angle, which is known as 135 degree as per IS standard. Now, in case of fixed beam, now if you see the nature of bending in case of fixed beams, fixed end beams, this is the nature of bending moment. Here, the difference between the simply supported beam and fixed beam is what? In case of simply supported beam, the bending moment at support is 0. But in case of fixed beam, because of fixity, some moment is attracted towards the support. Some moment from the mid, it is attracted towards the support because of fixity. So in case of fixed beam, when the condition of the beam is with fixed end, we provide one more bar at top. So the purpose of providing one more bar at top is to carry the moment at support, which is known as negative moment. That bar generally we provide in case of top portion of the beam, generally to carry the negative moment. If you see, they have done a bend, 90 degree bend in bars. So main purpose of this is what? To carry the bond stress. This length, whatever length it is provided, which is known as a development length or a anchorage length. So this length, how much length it is provided, should be as per IS standard. The length of the bend it is provided as per IS standards. One more, if the beam is bend, doubly reinforced. Now this top reinforcement whatever we have provided, this is in case of simply supported beam, which is known as hanger bar. But in case of doubly reinforced beam, we provide a bar at top generally to carry compression force because it is doubly reinforced beam. Doubly reinforced means what? We provide a bar at top as at bottom as well as top. So top reinforcement is provided to carry the compression force. Okay. Now one more thing, the depth factor in case of designer beam. So this is a very important factor in case of designer beam. So this is a depth factor which is depend upon the moment capacity of the beam. It is refer cantilever beam. In case of cantilever beam, we provide a varying depth. This is what, because in case of cantilever beam, the movement towards the support is maximum and movement at the free end is zero. So if you provide a uniform depth, so that is a loss of material. That section will be unequal. So that's why in case of cantilever beam, we provide a varying depth, maximum at the support, minimum at the free end. But in case of simply supported beam or continuous beam, we provide uniform depth. So this is the basic difference between a simply supported beam, continuous beam, cantilever beam. Also in case of cantilever beam, we provide a main reinforcement as top. Main reinforcement at top because there is a bending at top. So therefore we provide a main reinforcement in case of cantilever beam at top. So this is the basic difference between a simply supported beam, continuous beam and cantilever beam. Okay, we'll end up today here. So thank you for listening me.